Today we're going to talk about the product and quotient of complex numbers in polar form. Now notice this example that I have written right here. I have a product of two complex numbers, but these are in rectangular form. And we know how to deal with problems like this, and also how to deal with a problem where there are quotients. Well, these are both in rectangular form. However, what happens when they're written in polar form, such as if we're asked to find the product of 7, 35 degrees and 3, 15 degrees. So the first thing we want to do is write this in terms of cosine and sine. So this first one we can write as 7 times cosine of 35 degrees plus I times sine of 35 degrees. The second point we can write as 3 times cosine 15 degrees plus I sine of 15 degrees. And remember, we're asked to find a product of this, so I'm going to multiply these two. When we take the product of two polar coordinates, what we do is this. We take the product of our radii, so 7 times 3, and then in parentheses we write cosine of the sum of the angles, so 35 degrees plus 15 degrees. And that's just for the cosine term. Then we attach the sine term as well, and we take the sum of the inside angles, which is 15, let's go with 35 first. 35 degrees plus 15 degrees. And then we just simplify this. So this becomes 21 of cosine of 50 degrees plus I sine of 50 degrees. And there we go. We can write then, since this is our r, and this is our theta, actually these two are theta, then if we rewrite this in polar form, it becomes 21, 50 degrees. So this is the product of these 2 points. Now we're asked to rewrite this into rectangular form. Remember, rectangular form is the x plus I, y form, so we need to get rid of this sine and cosine thing. So in order to do that, it's pretty simple. I'm just going to rewrite part of this down here. Well, I'm going to keep that 21. And then what I'm going to do now is use my calculator to figure out what cosine 50 degrees is and what sine of 50 degrees is. The reason why is because on our unit circle we don't have 50 degrees, but that's not to say that we can't use our calculators. So in your calculator, we see that cosine 50 degrees is 0.64 and sine of 50 degrees is 0.76. Or maybe I should round that up to 0.77. Now what we're going to do is distribute this radius into these two terms. So take the product of 21 times 0.64, that gives us 13.5. And if I take the product of 21 with 0.77, that gives us 16.1, and let's not forget that I. So we've rewritten something that was in terms of in polar form into rectangular form. So let's do another example. We're asked to find a product between these 2 points. First thing we should do is rewrite these polar coordinates into the polar form with the cosine and sine. So I've rewritten the first point as 5 times cosine 3 pi over 4 plus I sine 3 pi over 4. And then I've rewritten the second point as 6 times cosine 2 pi plus I sine of 2 pi. And remember, we're asked to find the product of these things. So to take the product of this, I take the product of the radii, which is 5 times 6. Then I play with some cosine and sine stuff. So I take cosine of the sum of the two angles. So 3 pi over 4 plus 2 pi, and then plus I sine of 3 pi over 4 plus 2 pi. And now it just comes down to simplifying. So I know 5 times 6 is 30. And I need to figure out what each of these sums are. So 3 pi over 4 plus 2 pi. I know I need a common denominator, so I'm going to multiply this by 4 over 4. So that's 8 pi over 4 plus 3 pi over 4, which gives us 11 pi over 4. So here we have 11 pi over 4. And same game here, multiply top and bottom by 4, so we get the same thing, 11 pi over 4. And let's just rewrite this into a polar coordinate. And I know that this is then 30, comma, 11 pi over 4, because remember, these two values are our theta, and this one is my radius. Now, if I were to ask you to write this into rectangular form, we can actually do this on our unit circle. I know on our unit circle we don't see 11 pi over 4, but here's the thing. 11 pi over 4 is the same thing as 8 pi plus 3 pi over 4. And you remember, 8 pi divided by 4 actually reduces to be something. What does this really become? That's really 2 pi plus 3 pi over 4. So on our unit circle, I know that this will go around more than once and then go back a little bit, a little further out, and it actually lands at 3 pi over 4, which I think is on our unit circle. And that point at 3 pi over 4 is negative root 2 over 2, comma root 2 over 2. So therefore, we can rewrite this polar form into 30 times negative root 2 over 2 plus root 2 over 2, because cosine at 11 pi over 4 is negative root 2 over 2, that's what I've written here, and sine at 11 pi over 4 is really the same thing as root 2 over 2, which I've written here. So now if we distribute this into these two terms, we get negative 30 over root 2 over 2 plus I 30 root 2 over 2. And you should notice that things cancel out, where 2 goes into 30 15 times, and 2 goes into 30 15 times here. So this is actually negative 15 root 2 plus I 15 root 2.